Starting with our first graph here, we want to see when the function is concave up and concave down, as well as the point of inflection. So in order to do this, we need the second derivative. Okay, so we're going to take the first derivative to get x squared minus x minus 2. The second derivative will just be 2x minus 1. So we need to set this equal to 0 and get x equals 1/2. Okay, so x equals 1/2, let's say, is somewhere around here. And now we use the second derivative test, or the second derivative number line, not test, and we test. Okay, to the left of 1/2, let's say we pick 0, plug it into my second derivative here, we get a negative. And if we plug in a positive 1 in here, we get positive 1. Okay, so clearly this is concave down and concave up. So we say that it's concave up from 1/2 to infinity. And here you have to be careful. At 1/2, it's a straight line, so there is no concavity there. And it's concave down from negative infinity to 1/2. And because at 1/2 the concavity changes, we say that the point of inflection is at 1/2, comma, negative 3/4. So you just have to plug in the 1/2 in here for x. So this is a simple example. Let's look at a more complicated. So let's find the second derivative. So first, let's do the first derivative. So these are nice because they're polynomials. Okay, so we're going to set this equal to 0 and get that x is equal to plus or minus 2 over root 3. Okay, now we're going to draw the number line. So again, this is 2 roots that we got. And then we want to plug it in. So the second derivative is a quadratic, right? So it's going to look something like this. And then at 0, it's negative 4. So it's a lot easier now to find where it's positive and negative. So obviously, it's going to be positive, negative, positive. And so it's concave up, concave down, concave up. So it's concave up from negative infinity to negative 2 over root 3 and 2 over root 3 to positive infinity. Concave down in between those, so it's negative 2 over root 3 to 2 over root 3. Notice at negative 2 over root 3 and 2 over root 3, the concavity changes from up down and then down up. So those are going to be points of inflection. So we're just going to plug it back into the original function to get the y value. And when we do that, we get 16 over 9. Let's go on to the next one. Okay, so this one is interesting because we have cusps here. So let's see how we handle that. Okay, so we obviously need the second derivative. Now let's find the first. So in order to find the first derivative, we have to use a chain rule. So bring down the power. So it's 3/4 times 2/3. That's 1/2. Keep the inside the same. Subtract 1. And then take the derivative of the inside. So this is just x times x squared minus 1 to the negative 1/3. Now for the second derivative, we have to also apply the product rule. The derivative of the first times the second plus the derivative of the second times the first Okay, so I'm just going to rewrite it over here. And let's see, I'm going to factor it out. So they looks like they both have x squared minus 1. The candidates are negative 1/3 and negative 4/3 as the exponent. So, okay, let me just write it over here. All right, so the exponent is negative 4/3. So you always pick the smaller one, which is negative 4/3. And now we have x squared minus 1 minus 2 over 3 x squared. So simplifying this, x squared minus 2/3 x squared is 1/3 x squared minus 1. And now we have our second derivative. We're going to set each factor equal to 0. So this one is when x is plus or minus 1. And this one is, let's see, plus or minus root 3. So we're going to put the number line. So we have a lot here to plot. Okay, so let's see. Might help to do this. Rewrite it. One thing to notice is that the denominator is raised to the 4th power, so that's always going to be greater than or equal to 0. The only times it's going to be 0 is when x is plus or minus 1. Okay, and we're not going to be including those points. So what I want to get to is the denominator is positive. Let's only focus on the numerator, which, because it's quadratic, we can easily graph this. We know that the roots are root 3 and negative root 3. The y-intercept is at negative 1, and it's opening up. Okay, so to the left of negative root 3, it's positive, and then negative, and then back to positive. Okay, so now we can say, where is it concave up, concave down? Oops. So this concave up, concave down, down, and then up. So concave up from negative infinity to negative root 3, and root 3 to positive infinity. Concave down everywhere else, so between negative root 3 and root 3. So now for the point of inflection, we have to check, when does the concavity change? So it obviously changes over here, concave up to concave down, and then over here, concave down to concave up. So that's plus or minus root 3, and plugging it in, we get 3 times the cube root of 3 over 4. Okay. Let's go on to the next one. So this one, we have an absolute value, and finding the derivative of absolute value is tricky. So let's try to use the graph to figure this out. We know that sine of x has a period of 2 pi. So this thing is going to go all the way up to 2 pi and negative 2 pi. And it's pretty much similar to sine of x. You break it up into 4 pieces to get your graph. And now it's just a matter of looking at it. So let's see. So you're looking at concave up, concave down, then point of inflection. Let's start from the left. Clearly, from the left, it looks like a U, right? So U's are concave up. So that's going to be from negative 2 pi. And then notice that negative pi over here, it's a straight line. So we're going to stop there. And then it goes concave down. So from negative pi to 0, concave down. At 0, it kind of looks like a cusp, right? So the concavity there, it's a very sharp point. You can't take the derivative. So it's neither concave up or concave down. So we have to skip over that and then continue from 0 to pi, because again at pi here, it's a straight line. But from pi to 2 pi, it switches back to concave up. So that's our concavity. And now let's look at where it changes concavity. So we said it changed it at the zeros here. Okay, so that was at negative pi comma 0 and pi comma 0. And it's very important here to see that at 0, 0 comma 0, it's not a point of inflection because it goes from concave down to concave down. If it changed concavity, then you would have to include it. Okay. All right, last example here. Oops. Okay, so yeah, this one it's a bit complicated. So let's find the derivative. So that'd just be negative 2 sine x minus root 2. And then the second derivative would just be negative 2 cosine x. Okay. Set that equal to 0. We're looking at negative pi to 3 pi over 2. So if we're looking at the unit circle, negative pi, 3 pi over 2. So when is cosine 0? Well, cosine is 0 only at these 2 points. So let's start from negative pi. We go to negative pi. This is another way of saying negative pi over 2. And then we go up here to pi over 2. And then all the way down to 3 pi over 2. Okay, so that's our points that we need. So I'm going to put on the graph here. So that's about negative pi over 2. So around here is pi over 2. And yeah, 3 pi over 2 is at the end there. Okay, so it's concave up. Well, we can do the number line. So we have negative pi over 2, pi over 2, and 3 pi over 2. 3 pi over 2 is where it ends, so we should not include anything over here. So let's look at the left of negative pi over 2. So in between negative pi, I guess we can pick negative pi because that's, that's the bound here. It's negative pi. So okay. So these are the bounds. Yeah, we plug in number left of negative pi over 2, so let's say negative pi. Cosine of negative pi is negative 1 times negative 2 is positive 2. So this thing is positive. Pick here is 0, it's a good one. Cosine of 0 is 1 times negative 2 is negative. And then here we can pick 3 pi over 2. Or actually to the left. So let's pick pi. Yeah, that's a good one. Cosine of pi is negative 1 times negative 2 is positive. Okay, so this will be concave up, concave down, concave up. Okay, so we can write the interval. So actually here, we're not going from negative infinity. We're saying the interval is from negative pi to 3 pi over 2. So that's from negative pi to negative pi over 2. And then pi over 2 to 3 pi over 2. concave down in between, so negative pi over 2 to pi over 2. And for the point of inflection, we have to see when it changes concavity. So a negative pi over 2 changes from concave up to concave down, and at pi over 2, it changes from concave down to concave up. So that's negative pi over 2 and root 2 over 2 pi, and pi over 2 negative root 2 over 2 pi.